Hi everyone, my name is Emmanuel. My real job is making a cool open source end-to-end encrypted data sharing solution that is now used by the French government. I'm really happy about that. But I'm here to talk to you about something totally unrelated, which is online voting. And so as you may know, last year we had the French presidential election, and before that there was a multiple primary election held by a political party. And the interesting thing about that is they were all held with online voting, and they all use the same software, the same solution, which is NeoVote. So what is NeoVote? Basically, it's the leader in online voting in France. It is used by plenty of different big companies and even public university. And now political election. But the bad thing about NeoVote is it's a total black box. There is absolutely no information about what they do internally. I mean, this is from their website. This is the only technical thing there is. So really few information about what does it do. So anyway, I wanted to vote for the Green Party primary election. So I won't talk to you about how the website works because I don't have time. Anyway, at the end, when I finally voted, I got this screen. And on the screen, there is this weird thing. It looks like hexadecimal code. And it's called a proof of vote. So they said something like, great success, you have voted, everything's fine. Now you can take this thing, which is your proof of vote, and take it, don't share it, and you will be able to validate that your vote is within the ballot box later on. So I contacted NeoVote to have more information about that. They are really kind to answer me. And they said, yeah, don't worry, the day the result of the election will be available, you will be able to check this. So fair enough. The day of the result of the election. So we can see Yannick Jadot won. And as I said, here they provide you a website here and a password. And so they say, go to this website. So here is the website. You go to the website. You enter the address of the server you voted on, the password, you proof of vote, and then it crashed. So yeah, I single-handedly DDoS the thing. So, but it's okay, because the thing about it, maybe, I don't know, because there is a cache system, so if you retry enough time, after something like 20, 30 minutes, you finally got the result. And so they said, okay, your vote is valid, everything's fine, here is the result. Okay, so far, so good. But there is this thing. Yeah. So it's really cool. I mean, they said, okay, if you don't have time, you can use this website. If you don't want to trust, and you should not trust, of course, then you can download the source code. So I downloaded the source code. Spoiler alert, since I provided my input and provided my funding, they remove the possibility to download the code. So whatever. There is this transparency script, which is a PHP script. I don't have time to talk too much about it, but as a computing engineer, I have nightmare about this code. Whatever. So basically, what this script does, it downloads two archives from the website you voted on. Then it will check that your proof of vote contains the right thing compared to the archive, and then do redo ballot box counting. So we can have a look at the proof of vote format. So as you can see, it's kind of base 64. If you remove the base 64, inside it's AES encrypted with an hard-coded key. So, of course, I asked NeoVote about this, and they said, no, it's fine. Everything's fine. Don't worry. This is not for encryption purpose. It's for padding. So why not use a real padding algorithm? What for? Because the input data are always the same size, so I don't understand why they do this, but there is no documentation, so you don't know about it. Whatever. By the way, there is a bug here in the code. They just use this as is, and they should have converted to binary before. That's a small thing, but it shows you that weak typing is a bad thing. Anyway, so the inside of the proof of vote, as you can see, there is a header, there is some random bytes, and there is 5 hashes. So the idea is 1 hashes correspond to 1 vote, and you have multiple hashes so that your proof of vote cannot show for who you voted for. Okay, fine. The bad thing is there is no cryptographic signature, which means we can write a simple Python script and generate a fake proof of vote. And if we generate a fake proof of vote, what happened? The website say something wrong occurred. You might say that's normal, it's a fake proof of vote. But what does it mean is if you have a fake proof of vote and a genuine ballot, you get this result. If you have a genuine proof of vote and someone has tampered the ballot box, you get the same result. And it's totally the same. You cannot say which one is which one. So what does it mean is, if there is an election with no vote, you can create a fake proof of vote and say something went wrong, the election is rigged. And if you are not an attacker, if you are a regular person that say, oh, my genuine proof of vote doesn't work, they can go to you and say, you are an attacker. You created a fake proof of vote and you're lying. So, proof of vote. Now let's see the ballot box format. So, as I said, the ballot box is divided into two archives. The first one is called ballot key. It contains only RSA key. They say it's PM, but it's not PM. Whatever. And the second one, which is much more interesting, contains much more things. It's a ballot box. And first, there is some metadata, not really interesting. Then you have two folders, one per turn in the election. And inside those folders, you have three files. So we are going to see what they contain. The first one, object name, it contains a reference between the name of the candidate and an ID. The second one, not really interesting, configuration. I'm pretty sure we can hack with this, but I didn't play long enough to do that. And the last one, which is by far the bigger one, ballot data, which contain one line per vote. So it contains all the votes for the election. If you have a look at this thing, you can see that the second part, is the SHA-512 of the first part. So the second part is what's inside your proof of vote. For the first part, once you decoded it inside with RSA, you got this. So this part is random. I don't have time, but and the first thing is, of course, the ID of the candidate you voted for. Okay, so now it's time to have some fun. So what we've seen is the ballot box is not signed, so we can modify it, and everything's fine. We have the RSA key, we have all the hashes, we have all the data. We can do basically whatever we want. So, for instance, one attack we can do is just changing this file. I mean, for instance, this ballot, the guy voted for Yannick Jadot, but if we change this, now he has voted for Sandrine Rousseau. I mean, simple. And so if we do that, we regenerate the ballot box, we hosted it on our own server, and then we use the official website to do the check, and everything works. The proof of vote is happy. And as you can see now, we have Sandrine Rousseau who have won, and so we have just switched the candidates. So that's the first incredibly simple attack. I mean, you really need a notepad, 7-zip. I mean, you don't need to be technical, nothing, and you can just do that. People who use the proof of vote won't be able to see there's something wrong occurred, but for the organizer, I guess it's pretty visible because it seems like the right thing to do, that before the election you say, okay, this ID corresponds to this candidate and we will check this afterward. So you can find better attack. I said we have the RSA key, the private key, and with the private key you can retrieve the public key, and with the public key you can do encryption, and so you can generate new votes. So we can do the old way of adding new vote inside the ballot box. So really simple. We generate a new vote, we encrypt them, we add them to the ballot file, and that's it. So it still works. The attack is a bit less elegant because now we have the wrong number of voter, of course, because we have added votes. But it's more complicated, so it's really visible to the organizer still. But for the people who use proof of vote to verify, they can see things. So now we have a third one, and there is this file. Maybe you've seen. I didn't talk about because it's the funny file. So this file contains a list of hashes that you have to ignore. So that's great, because what does it mean is we can generate all the fake votes we need, then we add them to the ballots data, and then we remove some votes to have the right number of votes, and those removed votes, we take the hashes and we put them into extrahashes.csv. And once we've done that, everything's fine. So we have the right number of ballots, everything is valid, all the proof of vote are okay, and now we have some results which are warned with 2 more votes than the unique shadow. Right. So yeah, it's totally invisible to the voters. It's totally invisible to the organizer too. And the only thing is the file extrahashes.csv. It used to have only 24 hashes, and now it has like something like 3,000. But I mean, it used to be 24, now it's 3,000. Why 24 before? One now 3,000. Nobody knows. So seems okay. So you may wonder what the bot says about that, because of course I send them all those data, and they say it's really misleading. It's a fake attack. It's not something which is a real attack, because the only source of trust is the ballot box that is inside the NeoVote server. So I modified locally my ballot box, but it's not genuine. It's not a real attack, because you have to modify the server one. So basically what does it mean is, as long as you trust NeoVote for hosting the right ballot box, then you can use the validation tool to validate that NeoVote hasn't made something wrong. Okay. So here is a little list of everything wrong that occurred. How much time do I still have? 15. I was that fast? I have plenty of bonus. Sorry? Yeah, because my conference was originally 45 minutes long, so I say, okay, I have to cut things. So maybe I should have used okay, anyway, I have plenty of time, I can speak of plenty of stuff, I have bonuses, don't worry. So, we are going to just, we'll see this later. You can try all the thing yourself if you want. For instance, if you happen to be in a company or in a public university that use NeoVote, you can get in touch with me. You can use my GitHub repo, where there is all the script to modify the ballot box to create the fake proof of vote. So if in the next election we have plenty of wrong, proof of votes that doesn't add up, who knows? Okay, and so yeah, I started this thing alone, but quickly enough, I was joined by people from the CNRS. A researcher, which is called Enka Blanchard, great people. And so, she does a really great job at making this more, scientific-centric. And so we published a paper with this. So this is the first paper we published in French. And NeoVote, they tried to sue us. I mean, they tried to sue the CNRS and the CCSD. It didn't went very far, but... And the second one was eVote ID this summer. They got a prize, best paper, so great. This is the paper. I mean, if you're interested in this and you want something which is more academic, you really should check this paper. So I'm supposed to finish, but I have plenty of time, so I will switch to the bonus. Yeah, because I didn't talk about the website, the NeoVote website. So here is basically the website. I mean, it's a regular website, JavaScript, HTML, you know. So if I remove the uglifying, the unifying, we can see here with some indent. We can see the name of the variable are all changed with gibberish, so it cannot do much more. But there is some variable which are not, because they are closures. So the name matter in the code. And what we can do with this is we can search on GitHub. And so if we do that, we see there is one library which is named ASM Crypto, which uses those names. The sad news about ASM Crypto, if we check the code, so here you see NeoVote website, here you see the ASM Crypto, you see it's really, really similar. So they must be using this crypto library. And okay, so now this crypto library is basically a one-man job. It has not been updated in 2 years. There is, of course, no security audit. So yeah, not the best cryptographic library to do something like online voting. But there is something that doesn't add up. Is they use one specific algorithm, which is RSA, PKCS, whatever. And this thing is not implemented inside ASM Crypto. But there is a pull request, an open pull request that implement this. And of course they use it. Yeah. Bleeding edge. So, let's have another little fun thing. You know, the ballot box, their archives, they are password protected. But I couldn't open the archive on Windows. I mean, what's the name? Ballot key, I couldn't open it on Windows, wrong password. And the other archive, ballot box, I couldn't open it on Linux, wrong password. So, anyone has any guess? You want a hint? Oh. Yeah, you're right. Because the zip format doesn't use Unicode for the password. It uses bytes. So it's up to the operating system to choose which encoding use. And so, yeah, using accent there is not the great idea. But I'm sure you wonder, in the PHP script, they must open those archives. So how do they do? This is the code. And you can see that they just try. They try as is, then they do UTF-8 to ISO, and then ISO to UTF-8. I mean, they could choose. They could choose one encoding. They could choose not to use Unicode. They could choose whatever, and they choose this. Another bonus. Yes, it can. Oh yeah, great. So I was talking to you about the vote and this part of the vote, which was random. So if I had a look inside the website and I saw the place where this thing is done, so it's really random stuff. But they don't just take the random bytes and put them here. They do some stuff because you see this is printable characters. So this thing is bytes, basically. So we see it as only printable characters, but they should be able to have non-printable. But this thing is only printable character. So what does it mean is, sorry, I will switch this and we'll see it later. What does it mean is basically the randomness of the bytes they provide is really narrow. And the really funny thing is it's not even equally distributed. So the algorithms they use to take real random bytes and turn them into their less random bytes is this one, which is funny because they do a modulo 25 instead of modulo 26. I don't know why. And yeah, the funny part is this thing is then encrypted into RSA. And so RSA, PKCS, this algorithm, it works like this. You have a header, then you have random bytes, real random bytes, and then you have the 0, and then your message. Neobot uses 3072 bytes long key, so that's why. And so the funny thing is, this is real cryptographically secure bytes, and this is a message, and so they try to put as much less cryptographically secure bytes as they can to replace the secure one. So I have the feeling that they didn't quite read this thing and realize that they could just take this, ignore this, and this will be filled with correct bytes. Yeah, you should read the spec. The good thing is PKCS is well done, so there is at least I don't remember, something like 8 bytes, which are always random, so it's not a security issue. but it would have been if not the people behind PKCS have thought this well. And the final bonus, error handling. I told you about the PHP script that caused me some nightmare. Sorry, so this code is copyrighted. It's not open source, so I cannot show a full, but I can just choose one example and just try to make the most of it. So I choose this example. You can see there is this ballot counting. So okay, the thing does ballot counting, and if something goes wrong, there is this return code. So now return code, if it's 98, it means that it's timeout. So timeout means we have to store the data on disk. So okay, the store, but it may fail. So if it fails, then you have error code that is 1 and error point, which is 40 plus red code divided by 1000. And if the red code is 2, 3, 5, 6, but not 4, then error code is 6 and error point is 28 plus return code divided by 1000. And you break 2, which PHP instruction means you return from 2 loops. Yeah. Great code. So anyway, I think I'm done. I can go to... So here is the list of stuff that are not that great. And basically I'm done.
Okay, so thank you. We can applaud. So thank you for your conference. Do you have any question? Yeah, there is some question here. Just switch on the mic, please.
Hello. Thanks for your presentation. Did you get the opportunity to look at the system that was used for the last legislative election in France that used a different software from a different company?
No. I only have a look at this.
Okay. So, I don't think it's this bad in official elections, but if you want to look at it.
The CNRS, I think they started looking at it. I'm not sure.
There are another question on the top.
Hello. If we were to ask you privately, could you give the PHP code?
I guess we can talk about it.
Cool.
Thank you for your presentation. Terrifying. You talked about some hashes that were kind of shadow banned.
Yeah.
And so you added some hashes to see if they were shadow banned, but have you tried to remove the 24 hashes and see what happens?
The thing is, if you remove the 24 hashes, everything goes fine, except for some people which have a proof of vote which contain those hashes. My guess, because it's only a guess, as I said, there's no documentation, is when the server starts, there is absolutely no hashing, of course, and the first person has to vote. So he provides his vote, he has only 1 hashes, and so we have to give him 4 more hashes, which are those dummy hashes. And so 24 hashes, I guess it's because they have 6 servers.
Great. Thank you very much.
We have time for extra question. So in the middle. Oops. And okay, perfect.
Hey, awesome talk, man. Does the source code leak or release contains only verification and standalone, or is that backend stuff?
You mean the PHP script?
Yep.
It's just one single file, really simple.
Okay.
It could be
thanks.
more simple, but it's just not really complicated PHP script.
Could you give the micro just 4 rows in the top, please? Yes, perfect.
Hello. Were you approached either by NeoVote or any more serious developers or companies that would like to develop something more serious? Or
the very first thing I did when I had those funding is provide them to NeoVote. So yeah, something might be broken. I want to write an article about this. Do you want to say something about that? Do you want to fix before I release? And basically they got really angry and they said that everything I do is basically fake, and so it's not real issues that I'm showing. So we couldn't do much more with NeoVote. They threatened legal action against me, against the CNRS. They did legal action against the CNRS. So yes, that's quite something. And now for doing better online voting, yeah, there is people which are doing research in online voting. I'm not an expert on online voting, but now I've talked to a good number of people who do online voting as a researcher, and basically what I understand is doing online voting is it just doesn't work. Basically, you want to have a physical proof of your vote, and when you at the moment you use a computer, the physical proof of your vote is basically you typing on a keyboard, and everything that goes after that is into the void, and you cannot do any trust.
Thanks. I was afraid you would answer that for the first part of your answer.
So, okay, last one.
Hello, great presentation. Based on the answer you provided just right now, that it touches like on culture, it also touches on the way that these kind of companies approach researchers like you, that I understand you are independent. What's the ideal strategy, in your opinion, if we are having elections, like, for example, 4 months from now, to approach this task of securing the software? For me, it's about some trade-offs. If you choose to open it to everybody, you may have some countries interested in messing up with that. People might be like, oh, everybody is messing up with the software. If you don't have it open, you run into the problem that just a little group of people is seeing the source code. What's your opinion?
I'm not a researcher in this field of area, so I don't feel like my opinion has a lot of value on this. I'm just a regular people. So I think if you want a better answer, you should ask the people at CNRS, because they are the real person doing this.
One final question. Oh, okay.
Thank you. I'm checking their website now, and they claim to have homologation from everyone, like Neil, ANSI,
including
DGSI, etc. Where is it? Where is the homologation? Can we connect to those agencies and see what's going on?
The funny thing is, most of the accreditation they have from organizations, those organizations don't give accreditation. So basically they said, we've done an election with this fancy thing, so we got accreditation.
But it's fake publicity.
Yeah. And if you're on the website, at the bottom of the website, there is a link, which is the name Accès Electeur, something like that. If you click there is a list of web server, and they are all their web server. And so if you click randomly, most of them are not online, but some of them are, and they are real clients that are doing a real election. So you can write a simple script and just see in real time all their clients and what they are doing.
So thank you again. We can thank again Emmanuel for the talk.